Hello, this is my demonstration video for EE542 Lab Assignment number 1. So the first step in this specific lab is installation of Linux operating system as a virtual machine in my Windows system. So I'm using VirtualBox to install the virtual machine, and my Ubuntu version is 18.04. So to install the virtual machine, I have downloaded the ISO image file from the Ubuntu website, and I will be going ahead with the installation now. So this is the ISO file which I have downloaded from the Ubuntu website, and this is a random test VM which I won't be using. So I'll just name it something. It's test. This is the RAM which will be used in the virtual machine, so I'll just set it to around 6 GB. And this is the amount of memory which will be allocated. I'm leaving all these options as default because anyway I will not be using the specific VM. So now the VM is created. Now I'll just start it. For the first boot up, it's always slow. So yeah, so this is the uh, boot up image from the ISO file. So I'll just install Ubuntu and continue with the default English option, normal installation, download updates. So here the uh, virtual disk will be erased and we install the Ubuntu onto the virtual disk. So the installation can be done in this way. I have already performed the installation, and I have also uh, installed the necessary packages such as GCC, Perl, and NetTools and the SSH server. So I will not be going ahead with the installation now. And I've also added the guest additions to in order to like enable bidirectional copy pasting between the host operating system and the guest operating system. And I've also enabled SSH so that I can use an SSH client such as MOBA, Hexterm, and in order to connect to the different virtual machines which I've created. So yeah, I will close this and remove this. Yeah, so the next step is to simulate a computer network with the different virtual machines in VirtualBox. So for this specific network which is being simulated, we have three hosts, PC1, PC2, and PC3, and we have three routers, R1, R2, and R3. So we also specify the networks which the different connections are present. So between the PC1 and router 1, the network which is present is 192.168.1.0/24. And yeah, so for each individual connection, there's a different network. So I have already created the PC1, PC2, R1, and R2 and performed all the necessary configurations which are necessary. So I will be doing an example configuration with PC3 and router 3. Okay, so we can see that PC3 has only is connected to only one another virtual machine, and the network which it belongs to is 192.168.3.0. So this the IP address will be configured inside the VM. So I just need to perform this connection of router 3 to PC3 in the virtual box. And I also I am using SSH to connect to the different virtual machines because my system does not have uh, good a good RAM so that I can like start all the 6 machines concurrently. So once the virtual machine is created, you can create clones of this specific virtual machine to create different VMs with the same operating system and same configurations. So I'll be creating a clone. So as I said, I just need to create PC3 and router 3. So when we are creating a new virtual machine, we need to generate new MAC addresses for all the network adapters because we need new interfaces for all of them. We can't use the same MAC address. And we are creating a linked clone because the virtual hard disk files will be tied to its original machine and you will not be able to move the virtual machine to a different computer. So basically you are using less memory. So I created the virtual machine. Now I need to add the network details and add SSH port forwarding. So the in the network by default the adapter 1 is used to connect to the network address translator which is connected to the host operating system. So we can perform port forwarding here. So with SSH I will be connecting to the host port. uh, yeah, so I can connect to this host port 14503 and it will forward it to the guest VM's port 22, which is the default port for SSH connections. Since I've already enabled SSH, I don't need to do anything inside the guest VM. I just need to configure this so that I can connect to the uh, guest VM using SSH. And I also need to create another adapter to connect to the router 3. So here the network details are provided here in this slide. So for PC3 the name of the network adapter is internal network 3, so intnet 3. So the configuration is done, the adapter information is shown here as intnet 3. Now I need to configure router 3. So I'll clone another machine and add the required connections. So first I will generate the port forwarding rule. And I will enable adapter 2, 3 and 4 because router 3 is connected to router 1, router 2 and it's also connected to PC3. So the adapter 2 is connected to PC3 which is in intnet 3 and the other two connections are for uh, router 2 and router 1. So we can see 3 adapters are being shown here. Let me just confirm that. Yeah, so it's INTnet 3, 101 and 102. If you see 101 is connected to router 1 and 102 is connected to router 2. And I have already created the necessary connections for router 1, router 2, PC1 and PC2. So now we have made the connection, so we just need to set the IP address. So in this case, we are statically setting the IP address for all the routers and the PCs, and we are enabling routing between the routers using a tool called QUAGGA. So we need to run bash scripts for that. So let me just start the 6 different VMs. So I will be using the headless start so that the amount of memory used is less. Once the uh, VMs have started, I will be using the MOBA Xterm tool to connect to SSH into the guest VMs. Uh, you can also use Windows command line, but I just use this so that it's like more uh, user friendly for me. So I need 6 tabs because I'm connecting to 6 different VMs. So I have like configured the username and password is, username is EE542 and the ports are provided already. The port forwarding host ports which we have designed, which we have set in the rules previously. So so this localhost is the host name for the loopback address. So what happens is when we ping to the localhost with the specific port number, you're pinging yourself, meaning the same system. So all the data is like rerouted, and since we have set the rule so that the port with 14501 is forwarded to the guest OS port 22, we can SSH into the guest VM using this. So this is connected. I mean, so I've connected to all the 3 different hosts, and we'll also connect to the 3 different routers. Yeah, so everything is connected, so I just need to run the scripts. So let's look at the shell scripts and what they do. So for PC1, this is the example script. So we add the PC1 to the hostname file. So the hostname is changed to PC1, and we also add the host name resolution into this /etc/hosts file. So whenever we ping PC1, it pings to 127.0.1.1, and we also set the host name to PC1. So this /etc/network/interfaces contains the routing and the IP address information. So this ENP0S8 is the interface which is connected, which is the default interface for adapter 2 in the virtual machine. So basically we are setting the IP address statically here. So interface static IP address, and we are also providing the network mask, and we are routing all packets to the specific network into the router. So that this is the basic script, and once that is done, we just restart the networking service so that all the changes take effect in the in the guest VM. So I will be running this specific script. So I need to be in super user mode to run this specific script because we are restarting the network uh, service. So I'll just create a shell script file and add the script. So it's the same script which was there in the slide. So I'll provide permissions to the script file. Oh, so this is the router 3. So I'll just add the router script here instead of the. So the router script also looks similar, except we add the routing information using the QUAGGA package. So initially the same thing is done. We change the host name to router 3, and we also add a host name resolution. We had the host name resolution details into the specific file. We install the necessary packages required, and we add the routing information which is here. So we add the 3 different networks which are connected to router 3, and we add the IP address for each of the interfaces for router 3. So here in case of the PCs, we have only two a single interface, but here we have 3 different interfaces. So I'll just save the script. I'll just give permission again and run the script. And once this is running, I'll move to other VMs to run the scripts. So all the 3 routers scripts are running. I'll also run the PC scripts. So once all the scripts are uh, executed, I'll just reboot the system so that the changes take effect. So I lose the SSH connections. So once the systems are rebooted, I'll just restart the connection. So just to confirm, I'll just do if config and one of the, so this is PC1. I can see that the IP address for the PC1 is set up into ENP0S8 interface. So this is the IP address, which is what is shown here. So this is 192.168.1.0 network, and that's the first IP address. And for one of the routers as well, so if I do if config, we have the router's IP address here, which is connected to host PC1, which is the same network 192.168 dot 1.0, and yeah, the other networks are as well are shown here. So we have the interface IP addresses set up. Let's just do a check with the, so if I see the IP routes, those are also set up. Whatever data is going to the specific network is sent to ENP0S8. So ping and check the connectivity to another host. So it's 192.168.3.1, which is the IP address of PC3. So I'm pinging from PC1, and we can see that the ping is successful. Instead of ping, if I do trace route, so this is the IP address of R1, and then it should be R3 and then PC3, which is R3, so this is this specific address, and then this is PC3. So all the connections are working fine, and with this we can simulate a simple network with statically assigned IP addresses to all the interfaces. So yeah, now we are simulating a simpler network, but we will do some changes to the specific network. So I'll change the network so that only two hosts and a single router is present. So delete all the non actually I'll just delete all the VMs and create new ones. So I'll also change the network details. So I've changed the IP address of the network and also the interface IP addresses. So I'll just change that. So only one adapter is used here, which is connecting to R1, and R1 has three adapters to connect to both PC1 and PC2. So this is one, this is connected to PC2, and this one will be connected to PC2. Uh, this one is connected to PC1, and this is connected to PC2. Okay, then PC2. That should be it. So I'll just start all three of them. So this connection is stopped. Oh, so I just need three of the tabs. I'll remove the other ones. And I changed the port numbers, but the usernames remain the same because I've cloned from the same VM. So let me just take the port information. So this is host PC1, and this is PC2, and this is PC. Oh, this is router 1. So it's connected. So just run script similar to previous step. So here I have just changed the IP address of the network and created new route as well. So the script have finished running for the host, so I'll just reconnect to the hosts, and once the router is finished running, So in this specific network, I have updated the IP address of the two networks on the which are connected to PC1 and PC2. So this is a much simpler network as compared to the previous network. But in this network, there's no other difference. The IP addresses are still statically assigned. We just changed the IP address range of the networks for corresponding to the connections. So the script has finished running for the router as well. I'll just reboot the router. Yeah, so all three have finished rebooting. So I'll just ping to make sure the connections are working fine. Uh, so I'm pinging from PC1 to this is the IP address of PC2. So I'll just ping, and the ping seems to be working fine, which means the connection is set up properly. So this is just a two-host system network. So in the next step, we will just be replacing the network router with a vyos router, which has DHCP capabilities. So we do not need to assign the IP address uh, statically to the each individual host. So the vyos, there is a specific VM which has to be used specifically for uh, vyos, which is not the same as Ubuntu. So I'll just be adding that specific VM. So yeah, this is a different VM. I'll just leave the default options for the VM. So in this case, we need to stop running the router. So the router is stopped now. So just to confirm, let me ping. The ping is not responding, which means host now PC2 is now unreachable to PC1. So I'll be installing vyos. Username and password are both vyos. So we have the command line. So I'll just install the operating system onto the virtual disk. I'll change the password as well. Yeah, so it seems to be done. I just need to shut it down once so that I can do the network configuration. Yeah, so I won't be using port forwarding here, because I'm not connecting through SSH, I'll be using the OS directly. I just need to create two connections to PC1 and PC2. So instead of running R1, I'll be using vyos. So I'll just start this. Oh, before I start, I need to remove the ISO file so that it doesn't use a non-persistent operating system. So I'll be running these specific scripts. So initially I'll just configure the routing path so that routing will work properly, and then I will enable the DHCP server for both the first network, which is connected to PC1, and the second network. Okay, so let's do the configuration. So if we look at the interfaces, we have ETH1 and ETH2, which are the interfaces which are connected to PC1 and PC2. So I'll just set the IP address for these specific interfaces. So for ETH1, which is connected to PC1, I set the IP address specific to that specific network, and this is for ETH2. So let me just save details. And now if we look at the interfaces, we have IP addresses for ETH1 and ETH2. And if we look at the routes, these are added as well. And so just to confirm, I am able to ping again, which means the connection is proper. Yeah, so this is fine. So now let's set up the DHCP configuration. So this is ABC is a random name for one of the DHCP servers which I'll be setting up. So this is for the network connected to PC1. I will set the default router to the IP address of the router itself, and I'll also use it as the DNS server, and I'll set the lease time to be 86,400 seconds. And I also need to provide a range of addresses which can be assigned with from the DHCP server. You just commit and save. So one of the DHCP server is configured. Now I'll create another DHCP server. Which will have similar details. So I'll just set so for this specific network which is connected to PC2, I will set the router as the default router. So these are all the DHCP configurations which are required when a client asks for a IP address. And I'll also set it as the DNS server. Set the lease time to 86,400 seconds. Start and stop range as well is provided. So I'll just commit and just to confirm all the details. So you can see default router is set, lease is set, range is set, and the same is done for both the DHCP servers configured. So we've done the configuration. Now let me just commit and configure, commit. All the changes are committed. So let me just confirm. So you can see two pools are provided with 199 IP addresses. So now we need to do the changes in host PC1 and PC2 to remove the configuration with respect to the statically assigned IP address. So I'll just remove the IP address portion of this. So I will keep this up the gateway route because I need to still route the packets to the specific specific interface. That is done. I will restart the networking and do the same for host 2 as well. So I still see the old IP address. I may just restart the system. if we see here, the IP address is changed, and here as well. So I can confirm whether it is assigned by the DHCP server by looking at the statistics. We have one lease on both the networks, which means it's assigned to PC1 and PC2. So we can see that the IP address is dynamically assigned. Now, I will need to restart the networking again because sometimes the route which was configured in PC1 and PC2 does not seem to restart once the system is restarted. Once the networking service is restarted, it seems to be working. So you see the specific route is required because both of my hosts are in two different networks. So even though there's a default gateway configured, the PC2 is on a different network. So we still need to route the packets to the specific uh, interface. So let me just ping and confirm 128.125.254.254, which is the PC2 IP address, and ping is working. So with dynamically assigned IP address, oh no, that's the IP address of the router. This is the IP address of the host PC2, and ping is working, which means the connection is set up. Yeah, and the trace route is working as well. This is the IP address of router, and then from there it's going to the PC2. So now all the connections are set up properly. Now I will be running the socket programming code so to test the connections. So firstly we have a just a basic connection between PC1 and PC2. A single user with the server. We have a router in between, but yeah, just a single user connected to the server. So in this case, PC1 is treated as the client and PC2 is the server. So let me just start the, instead of running it in the using SSH, I'll just use the actual VM itself. So this is PC1, and this is PC2. So I'll just create a client code, and yeah, so the specific code, we provide the port number through the command line argument and the uh, host name as well. So with that, uh, the connection will be set up to with the server. So I just need to run the server code as well. So I'll set up the server first. So for the server, I need to provide some port. So I'll use 15700. So the server is started. I'll provide the IP address instead. So now the connection is set up. So let me just send a test message. The message is received here. So this is the basic connection setup. So this is seems to be working fine. So the issue with this method is that the server turns off after single connection. So you need to make sure the server is able to handle multiple clients. So what we are doing here is every time we accept a new client, we fork out a new child process. So if PID is like equal to 0, that means this is the child process, and else is in the parent process. So what we do is we close out the parent socket, which because when we fork out a process, all the socket descriptors and the file descriptors are copied as well. So in the child process, we don't need the parent socket, so which is closed, and then we call this do stuff function with the child socket. In this function, we just send the data using, we read the data which is sent by the client, and then we write some data into the client, and then we close the socket. So that's all that is happening. In the parent process, we don't need the child socket, so that is closed here. Okay, so I need to provide a port. Server is started. I'm able to connect with the client. I sent a message, and then the message is seen here. The server is not closed. I can connect with another. Yeah, so all the messages are seen here. But the issue with this uh, method is that there are many zombie processes for each of the child processes, which is like after we finish the processing of data, the child process is uh, it ends, but then the parent process does not read the exit status of the child process, because of which the zombie process is, the child process stays as a zombie process. If we look at all this five PIDs, these are in zombie state because we haven't closed the child process properly. Basically, the parent process has to read the exit status, and only then the child process can exit the system, exit like give out its PID. So for this, we have update and code. So here we have a signal handler. So what we create a signal handler. So the sick child signal is raised when a child process returns, basically. And what we do here is we reap the process. Basically, what happens is we call wait PID, and so what this does is we read the status at the parent process uh, for that specific child process, and we call it using the no hang uh, uh, no hang macro, so that the wait PID function is not blocking, so that we can run the accept command for the new child systems. So here you see, the child process is immediately terminated, and just confirm there are no defunct process or the zombie processes which are created. So that's with respect to TCP sockets. Now let's look at UDP sockets. So this is what we just did. We added the w no hang parameter so that the function is non-blocking, and from the parent process we called the wait function so that we obtain the status of the process so that the process can exit, the child process can exit. So the UDP server, we change the send and receive or read and write to send to and receive from, and this is a socket which does not provide acknowledgement to the sender, which means like it's not as reliable as TCP. So if we see here, there's a receive from function and send to function where we need to provide the addresses to connect to the client. And we also need to update the client code here. Because when the client has to use read send to and receive from. Let's start the server. So the message is sent from the client to the server. Now let's look at Unix sockets. So here both the sockets have to be in the same file system. So what we do is it can be used to like communicate between two different processes. It behaves similar to a queue where whatever is like input we provide from process 1 is read in process 2 in a FIFO order, first in first third order. So I will create two terminals and run in the same system because it has to be in the same file system. Yeah, so let me just. So here we have to provide a socket file name basically. So this is how we start. So my file name is sc, and if I do ls here, we see the sc file descriptor or socket descriptor, and I'll connect from the client to the same socket descriptor. So whatever I paste in the client is seen on the side of the server. So that's it. All the steps are covered in this lab assignment demonstration. Thank you.